So in this section, I wanted to just share the walkthrough of the workflow that I've seen across multiple companies on how they manage the molecular diagnostic workflow. Um, so I have some anonymized data in the sandbox that I'm going to go through the workflow and share what has worked, what hasn't worked, where the friction points were, what use cases I'm hearing from the industry. So we'll cover some of those pieces. So if you are building a molecular diagnostic AI company, or if you work in an existing molecular diagnostic AI company as a wet lab person, as a computational person, I think some of this will resonate with you. So let's get started. So in terms of the workflow, what I'm seeing is people use traditional electronic lab notebook and lab information management system, but the biggest challenge they see is the handoffs between different part of the workflow is making them lose the audit trail, making them lose the chain of custody, which is really important. That's one kind of friction point that I'll address in this workflow. Second thing I'm noticing is when companies come to us is they they do want to build the LLM infrastructure, but they cannot directly ingest data from ELN and LIMS that is cleansed enough that can go into their foundation model or their customized model that they're building in their generative AI infrastructure. So those are the two big things I'm hearing in the last few months. And I'm going to address both of them as I'm going to go through the use cases in this few slides. So in Scispot, we don't like to call it as an ELN LIMS. We like to call it as a data infrastructure. So think of this as an alternative to your old school LIMS systems where you struggle to address these use cases. In Scispot, what you can do is you can kick off a workflow. So in this case, I'm obviously focusing on the molecular diagnostic flow. And then you can decide what are the typical actions that you will take, right? So in this case, the actions I'm going to take is I'm going to start with sample data registration and go all the way through to generate report. And then I'm going to talk about those two friction points that I mentioned earlier in the slide. And as I start, I can scan multiple samples. So depending on your throughput and what kind of setup you have in the lab, you can either scan this through the gun or basically manually enter the samples in bulk as well. And once the samples are registered, within Scispot, there is a data lake called LabSheet. So all the data kind of go into this central data lake, if you will. You can see what those samples are. And then as you're registering the samples, you can then create child samples, meaning aliquot them, create derivatives, or whatever your workflow would be. But in this case, I'm just going to create a few child samples using DNA isolation and purification protocols. And then as I create this, the cool thing is that the chain of custody and the linkage between that is maintained. So you know what was your parent sample and how you did the aliquoting or created child samples and where the linkage is. So in this handoff of sample data registration to the next step, you have the chain of custody or audit trail maintained. And then the next thing is let's say now I want to start another workflow where I'm bringing data from the instrument. So depending on the instrument, this could be automated or semi-automated or manual. Again, depends on where the source data is coming from. The most common use cases I've seen is people use Scispot agent to take the data from their instrument Windows machine. So if it's qPCR, for example, it picks the data and then it pushes to the secure cloud, right? And once that data is in cloud, it becomes kind of semi-automated. So you can bring that data, and if it has metadata and results, you can see that in this lab sheet format, and connect it back to all the steps that you've done in the past. So that linkage never gets broken. And let's say if you have multiple folks within your wet lab team that are doing each of these operations, you don't have one person who does all of these steps. You can also assign that to individuals and track who's doing what, when, and how. And what that helps you is as an operations person or as a lab manager, you can track the handoffs. You can know at what stage your team is, so you can understand the cycle times between each of these stages. Okay, great. Now let's say I'm assigning this to a digital plate, whether that's 96, 384 multi-well plate. I can also push the data from well plate to the instrument. Again, I've seen manual to semi-automated to fully automated. There are some robotic labs who are fully automating this, but I'm seeing more manual and semi-automation here because in some cases labs do post-processing, some sort of transformation they like to do before that data is pushed. And for that, what they do is they write some Jupyter scripts. So Scispot has a Jupyter embedded hub where Your computational folks can write some Python scripts. We're working on like wet lab folks to use natural language to write some of those scripts as well. So you don't have to be technical as you're transforming some of this data. But for now, like you can add a script and computational folks can like use either our templates or write a script from scratch if you want to do certain types of post processing within these lab sheets. And then once this is done, like again, all of that is linked together and you can see the history. You can see like how things are navigating in each of these steps in the navigation on the left. And then one other thing I want to show is like in each of these steps, one of the things that we heard from everybody is, can I build like a graphical ontology, right? So can I see how things are progressing? So this kind of rather looks a bit messy, but you can filter this by samples, filter this by runs, filter this by like actual event that you've done in this flow. And what this does is it shows you the chain of custody in a knowledge graph as well, which is super useful because a lot of customers mention, hey, I have to run SQL queries to find the information, or I have to like hit this API endpoint and then slice and dice the data to be able to see what sample was linked with what run, what experiment run, how was it like sequenced, what instrument that came from. So there's a lot of questions that folks go through, and the idea of like graphical ontologies is, can we connect all of that together? Can we bring that data in one chain of custody? The other advantage is like if you're building a proprietary database, let's say you're building an LLM infrastructure, one question I've heard is, can I train that with these graphical ontologies? So Scispot has an API endpoint. You can check that on docs.scispot.com. I'll put a link in the chat as well. But you can hit that endpoint to be able to, like, if you're feeding this as a training data set in your foundation models, you can do that, right? So the goal is that if you are using an old school ENN and LIMS, that gives you an endpoint that cannot connect easily with your LLM infrastructure. The goal is to like minimize that friction, right? So you basically use a modern data infrastructure where you can use the training data set for your particular use cases. The other aspect that I've seen from some of the companies, especially Series B, Series C stage, so not pre-seed, seed stage, is as they get more mature in terms of their data maturity, AI readiness, they want to be able to like contextualize some of these ontologies. Meaning they want to like put a score or some sort of weightage of like what nodes or what tokenization would make sense for them. And they're basically building their in-house models to be able to contextualize some of this information, meaning train this based on the weightage that I have, or make sure that for this particular flow or this particular sequencing, you add this weightage to it. So there's a lot of like things you can do on top of this data as you're building your IP or as you're building your platform. Okay, the other thing I want to do is like, in this case, talk about like the report, which is also another big use case that you've seen is, can I automate my report generation as well? So this can be done in two ways. One is like using the generative AI report that Scispot generates based on like the workflow that you just saw. The other option is like you can provide prompts to this report, meaning like think of like you guys, if you use ChatGPT, you provide certain natural language prompts to get answers. So there are two options. One is like you just use the AI report that automatically gets generated for you, or you can fine tune it based on natural language and say like, only detail out the experiment that I ran on these samples. Do not cover everything. Or slice this data by the plates and the positions that I have, so I can just make a summarized report for that particular thing. So it all depends on the use cases. The prompts are limited for now, but our goal is like you can edit this report manually as well. So once the AI generated report is there, you can like edit the report manually too if you want to change this, before sharing it with your collaborators and partners. Okay, great. So I think that was like a high-level overview of the whole workflow in the slide that I just showed. But any questions would be great.